Okay, part 2, final review, Desmos. I'm going to cover slides 12, 13, 14, 15, 16, 17, and 19. So here we go. So, again, modeling a situation where we're going to be writing an equation, and then we're going to, and in this case, I don't think I've got, oh yeah, I do. Okay, cool. So I do have the equation that goes with this. So we'll be able to take a look at it and talk about possible solutions. But let's first get our equations written. So a day spa charges $75 for a 1-hour massage. And then each add-on, so I go into this day spa, I get a 1-hour massage, and if I want to have other services, each add-on is going to cost me, the customer, $15 more. So we can see here that they want us to use the variables of X and Y. They want X to represent the cost of each add-on that I make, and that Y is going to be the total cost of the 1-hour massage. So that's the total cost plus whatever number of add-ons that I do. So we're supposed to write an equation that represents the cost of a 1-hour massage with X number of add-ons. So the cost is Y, and that's going to be $75 plus 15X. So think about that. 75 plus 15X. 75 is the cost of my massage. $15 is each add-on. X is the number of add-ons that I do. And I don't know how many add-ons I would do. However, if for me to figure out the total cost, this is what I would write. So I'm going to actually answer this question right here based on my equation, what's a possible solution, on the next page. Because, as you can see, I've got my equation graphed. So after you would have inputted this into Desmos, it would have given you the red line. So now we're going to determine what could be a possible solution and what does the solution mean in the context of the problem. So down here, the X line represents the number of services that I get, and this is the total cost on the Y. So I can look at that and I can go, oh, here's my y-intercept right there. This is that $75 that costs basic massage, 1-hour massage. All right, so let's take a look. If I go and I look right here at this point, I like this point because it's an easy point for me to read. Or let's look at this one right here. So those 2 points are solutions. So let's do this. Let's write the ordered pair for each of those solutions. So what I did was I've got 2 points here. 1, 90. Here's the 90. 3, 120. I know that I'm counting by tens on the y-axis. All right. So 1, number of services, and if I were to get 1 service plus my $75 1-hour massage, it's going to cost me $90. How about this one? This means that I paid for a 1-hour massage at $75, and I bought 3 add-on services. Remember, each service is $15. So if I go 3 times 15 plus 75, my total cost would be $120. So I've done 2 possible solutions, and I explained what it meant in both of the contexts of the problem. Moving on now to the next slide. Slide number 13 has to do with this internet cafe, and that it charges customers $12 to start using the computers, and for every minute that you're on the computer, it's 10 cents. So they've given us this equation of C is equal to 12, which is $12 to start, and each minute I'm on, it's 10 cents. I'm supposed to rewrite the equation and solve for the variable of M. So what I'm going to do is I'm going to start by first writing my equation out. So I know most students like to move. Remember, we need to solve for M. M needs to be, as you can see, on the left-hand side. So in order for me to do that, the very first thing I'm going to do is I'm going to subtract 10 cents or 10 cents M, 0.10 M, from both sides. And when I do that, that gets eliminated on the right-hand side, and I'm left with C minus 0.10 M is equal to 12. So now I'm going to note that I need to move this C over, which means I'm going to subtract C from both sides. C minus C, that gets eliminated, left with 0.10 M is equal to 12 minus C. I'm going to divide both sides by negative 0.10, negative 0.10. Therefore, that becomes 1M is equal to, and what do I have? I have 12 minus C over negative 0.10. There is my answer. I've got M all by itself, and I've done a series of legal moves to move C over and get M all by itself. Okay? So you are going to be asked to solve for a very similar equation on the test. So if you didn't understand how I did this, I would suggest that you see me during office hours so I can go over it again. All right, moving on. Now we're on slide number 14, and we've got a graph here that shows the value of a washing machine as time goes by. So just take a look at this graph, and you can see that my graph is going down. Well, this makes sense because over time the value of my washing machine goes down. So that means the longer I own it, the less valuable it is. All right, so now we also know that we were given an equation, and this graph can be modeled by this equation, y plus 100t is equal to 500. So we've got, let's just note some other things, that t is on the x-axis, so t is equal to the time in years, and the value, v, is the value, this is on the y-axis. So that's the value of my washing machine in dollars. So let's select what it's asking us to do. Select all the statements that are true about this situation. All right, so let's look at situation number 1. The washing machine was worth $500 to start. So let's take a look. Right here, at 0 years, that means when I bought the washing machine, I paid $500. Absolutely correct. That is correct. True. After 1 year, the washing machine had lost $50 in value. So here's my 1 year mark right here. I'm going to go all the way up. I'm going to get the value here. So when x is 1, what's the value of y? 400. I didn't lose $50 because I started at 500, and after 1 year it was worth 400. So that's not true. After 5 years, the washing machine was worth absolutely nothing. So here's 5 years right here. What was the value of what was the y value? 0. That's true. It's worth nothing. That's 0. If 2 years had passed, the washing machine is valued at 300. So I'm going to look at 2 years right here. I'm going to bring this all the way up to it hits my line. I'm going to go over here. What's the value at 2 years? $300. Absolutely true. So it says here, for every year that goes by, the washing machine loses $100. Well, let's look at year 3. Right here. What is it worth at year 3? 200. So every year that it goes by, the value goes down 100. Absolutely. So that is also true. So what was true? 1, 3, 4, and 5. Hit submit. You should get them all correct. Moving on. Let's look at this next one. Oh, right here. We were correct. Moving on. Here's slide 15. Okay, so Margaret and Danny are separately saving for a PS5. It's on the hot ticket item this year. Margaret already has $50 in her piggy bank. Danny has $10 in his. So again, this is going to be a system of equations, talking about 2 different people. We're talking about Danny and Margaret. They're both wanting to buy a PS5. Margaret has $50 in her piggy bank. Danny has $10. Every week, Margaret saves $5. Every week, Danny saves $10. So, X is the number of weeks. Y is the amount of money in the piggy bank. We're supposed to create a system that will represent this situation. We need to write 2 equations. Let's write Margaret's equation and Danny's equation. All right, let's talk about Margaret. So what do we know? We know that Y is how much money she has in her piggy bank. So Y is equal to, what do we know? What did she start with? She started with $50 in her bank account. And how much did she save each week? Well, she saved $5 for every week. So I'm going to use X right here. So for every week that she is saving money, she saved $5. She started with 50. So this is Margaret's equation. How about Danny? Well, Y is equal to, again, because we're still talking about the amount of money in his piggy bank, how much did he start with? He started with 10. And what did he save every week? He saved $10 every week. If he saved that, that's this equation, and this equation is the system. They're related in that they're both saving for a PS5. They're both saving money in their piggy banks. We want Y to represent the amount of money in their piggy banks, and X being the number of weeks that they save their money. $5 each week for Margaret, 10 for Danny. Okay, so now if you input both of those, you would, on this next slide, see the equations that have been graphed. So, we know that those are the 2 equations, Margaret's and Danny's. So, I know that Danny's started at 10. So this is Danny's equation right here. And I know that Margaret's started at 50. This is Margaret's equation. All right, so now let's continue. Now we need to figure out what is the solution to the system and what does the solution represent. So remember, the solution is the point of intersection. So let's go ahead and write the ordered pair of that point of intersection. So you can see that I came down and drew a line all the way down to my x-axis, and I read that the graph was 8. So x is 8. Then I drew a line over to my y-axis, and I noted that every other, I counted by tens every other. So, or every 2 was 10, or every single line was 5. I just found it easier to count by tens. So if I was at 80 up here, 2 of them was 90. So 8, 90. So again, what does the x represent? X is the number of weeks. And what is the y? Money. So therefore, at 8 weeks, they have both saved $90. So the solution is 8, 90. What does it mean? 8 weeks, they have saved $90. So now, remember that the purple graph was Danny and the red graph was Margaret. And that I knew that from my previous slide. So now it's asking who is going to have enough money to buy the PS5 first. And just so you know, PS5 is $500. Take a look. Well, I'm going to say Danny, because right here at this point of intersection, his graph is growing faster. Margaret's is more flat. So Danny is going to reach $500 sooner because he's saving more money quicker over time. So let's go ahead and now look at the final, or these last 2 slides. Slide 17 is having you again read graphs. So we have 4 stores here. We have store A, B, C, and D. And for 10 weeks, 4 stores have recorded their sales. Lines A, B, C, and D are the graphs of the sales over 10 weeks. So here's 10 weeks. The graph, this must be the money. This is weeks. And now we have to do some selecting of all that apply based on the graphs. All right, so let's take a look. At week 10, I'm going to do this step by step. On week 10, store C sold more records than the other stores. Okay, so store C is the green line. I'm going to go right here. Here's week 10. Did they sell more? No, they didn't. They only sold this many. So that is not true. On week 1, store B sold more records. Week 1, right here. I'm going to go up till I find B right here. Here's B. Go over, take a look. Is that intersect? Take a look at these points of intersection. Absolutely, that is correct. So that is correct. Sold more records than any other store. All right. During the 10 weeks, the sales didn't change for store C. All right, so here's store C. They're flat. They didn't change. Absolutely correct. All right. Store C's sales decreased. We just said that they didn't change, so that's not true. Store B. Which one is store B? Gotta erase that. That's green. Did their sales decrease steadily? Store B. Yep. Went down. Definitely. All right. Moving on. Store A. Sales increased faster. Increased faster. So I'm going to erase all my points right here. We're going to look at store A. Did store A, so take a look, there's store A. Did that increase faster than store D's? Here's D. No, that's not true. Store A's graph is flatter than store D's, so this is not true. Store D's sales increase faster than the sales of store A. Yep, steeper, definitely. All right, so when you hit submit, that should all be correct. Last slide, slide 19. This is the one we did in class for both periods 3 and 6 today, but I'm going to go back over it again because I think it's a valuable slide. So, we've got a school play, and the drama club is selling tickets for the school play. So, the drama club sold a total of 375 tickets. Student tickets cost $4. Adult tickets cost $11. The drama club took in $2,620. We want to know how many adult tickets did they sell? How many student tickets did they sell? Again, system of equations. How do I know that? Because we are talking about the drama club selling tickets, but we're given two different pieces of information. We're given that they sold a total of 375 tickets, and we're also told that they made $2,620. So, we need to assign the variable that represents adult tickets and the variable that represents student tickets. You can use X and Y, or you can use A and S. So I'm going to go ahead and use A for adult tickets and S for student tickets. Just because it's easy to represent them with the variables that I'm given for adult A, S, student. All right, so let's break it down. Let's only talk about selling the total number of tickets. So we know that they sold a total of 375 tickets. What else do we know? We know that who made up the sales? Students and adults. So adults and students bought tickets. They sold 375 of them. This is the equation number 1. What about the second equation? Well, we know that they made $2,620. So what do we know about that $2,620? We know that they sold adult tickets and they sold student tickets. Well, how much was each adult ticket that they sold? Each adult ticket was $11, and each student ticket was $4. So the adult ticket is the A. We know that it was $11, $4 for each student ticket that they sold, and the total that they made was $2,620. This is equation number 2. This is my system. I know it's my system because we're talking about the school play, we're talking about the drama club. How is it different? One's talking about how many we sold. The other equation is talking about how much money we made. All right, so I can open up Desmos, and if I decided to use X and Y, I could have made adult X and student Y, or vice versa. It doesn't matter. And I could easily pull up Desmos and graph it. But because I didn't, I'm not going to. I'm simply going to use elimination. I'm going to eliminate one of the variables by multiplying the top equation by 4. So when I do that, I get 4a plus 4s is equal. Now I'm going to multiply 375 times 4. I got $1,500 or 1,500 when I multiplied everything by 4. And on the bottom, my second equation, I still have 11a plus 4s is equal to 2620. So, take a look there. Well, I need to eliminate the s. So, I'm going to subtract. In fact, I'm going to rewrite this and subtract the top equation from the bottom. So let me rewrite it to show you what I'm going to do. Okay, so all I did was rewrote, and I put the 4a on the bottom. I'm going to subtract. Now you're probably saying, well, Miss Sanafarth, couldn't you have just multiplied the top equation by -4? Yes, I could have, which would have changed this to -4a minus 4s. Could have done that easily, but I decided not to. I decided just to keep it the way we've been working on it in class. So now I'm going to subtract. 11 minus 4 is 7a. 4s minus 4s is 0. And now I'm going to subtract 2620 by 1,500, and I get 1120. Divide both sides by 7. I know that a is equal to, get 160. So what does that mean? A is equal to what? Remember, what did I make A? A was my adult tickets. So I sold 160 adult tickets. We'll go back up here. If I sold 160 adult tickets plus student tickets, I sold a total of 375. Well, I could figure out how many student tickets I bought by subtracting 160, and I get 215. So I sold 215 student tickets. Again, if you need me to go over this in more detail, come and see me during office hours all next week in the morning from 8 to 8:30.